CSS can now count elements, and while it sounds pretty basic, it lets us do very powerful calculations, such as animating cards one after another, or coloring items dynamically based on their position. Features where you would normally need JavaScript will now be possible with CSS only. The new functions are called sibling-index and sibling-count, and they let us know which item am I in a list of siblings, and how many items are there in total, which basically means we have a simplified version of a JavaScript loop built into CSS only. Let's take a look at a few examples. I have a few cards that I want to animate one after another. I start with a simple keyframes animation. I call it pop in, and animate to a scale of 1, and opacity of 1. That means, initially, every card should start at scale 0.5, meaning half the known size, and an opacity of 0. Let's apply this animation to the card's pixel looks. It takes 300 milliseconds, is out, and with forwards, I can keep the final animation state after the animation is done. Otherwise, it will jump back to its first frame. Now that will give us this animation. Right now, all cards pop in at the exact same time. But what we want is a staggered effect. So the first card pops in, and then the second card, and then the third card, and so on. For that, we need the animation delay property. If I set this to 1 second, every card waits 1 second before it animates. So the solution is not just adding a delay, because every card needs a different delay. And before this new feature, you would usually solve this with nth-child. But this hard-coded solution is not flexible, because if we add more cards, we need more CSS. So, instead, we can calculate the delay automatically with sibling-index. Sibling-index returns the position of the current card, so the first card has a sibling-index of 1, and for the second it's 2, and so on. So let's use the calc function to multiply the sibling-index with 1 second. That way, the first card has a 1 second delay, and the second card a 2 second delay, and so on. It does not matter how many counts I add to the HTML. The solution will always work. But for animation delays, we usually want the first count to start immediately without a delay. So I subtract 1. That way it starts counting from 0. And to make it faster, we don't have to use 1 second. I can use 30 milliseconds instead. And that will give me this animation. Now you know where to use sibling-index. But where can we use sibling-count? What is that for? Sibling-count returns the total number of siblings, and it can be very useful in the bird of colors. Let's say I want every count to have a slightly different background color, and the basic idea is sibling-index tells us where the current count is, and sibling-count tells us how many counts there are in total. So together we can turn the position of each count into a relative value, something like how far into the list am I? Am I currently at the first count, the middle, or at the end? And once we have that value, we can use it for colors. So let's say every count should have a different shade of blue. First, I create a custom property called progress. And inside, we take the sibling-index -1, same reason as before, we want to start at 0, and then we divide that by the total amount of siblings, -1. And this gives us a value between 0 and 1, so the first count is 0, and the last count is 1. And then every count in between gets a value somewhere in between. That is the use of bout, because now we can use the stroke as value inside the color. So on background color property, I use the OKLCH color format. The first value is the likeness. I want to start at 40%. Then I add all progress value, multiplied by 40%. That means the first count stays at 40% likeness. The last count reaches 80% likeness. And both counts between them are spread evenly across that range. The second value is the chroma, meaning how intense the color is. The last value is the hue, meaning the actual color on the color wheel. So now all counts stay in the same blue color. But they get brighter and brighter depending on their position. And the cool part is, if I add more cards, the shades automatically spread out again. So the steps between the cards are calculated automatically. I don't have to write this manually. So sibling-count is especially useful when the calculation depends on the total number of elements. And with sibling-index, we know the position of one card. And with both of them together, we can make that position relative to the whole group. Now before checking out the next example, you should know that browser support is still limited, and these functions currently don't work in Firefox yet. But this feature is definitely something to be excited about, because with some clever math, you can build something like this. I found this 3D image carousel animation built with just HTML and CSS. Now here's what he did to build this. First, he enables transform style preserve 3D, and then applies a rotate animation to the whole carousel. After that, each image calculates its own angle and distance using sibling-index and sibling-count, and visual trigonometry. Once CSS has those values, it can use them directly inside the transform property to rotate each image around the circle, and then push it forward in 3D space. And this really shows how powerful these new features can become by just letting CSS know which item is this in a list of siblings, and how many items are there in total. If you want to learn more about web development, watch this video next. My name is Fabian, and this was Coding to Go.